Okay, so the next part of chapter 12 this with our lottery event that we did, activity. But probability is just measures the chances of the event occurring. And so the desired outcome is what you're trying to get, right? We call that the success, or I call it the favorable thing. And any other outcome is the failure or unfavorable. So I'm going to give you these formulas. Think about this. So it says, if an event can succeed in S ways and fail in F ways, then the probability of success and failure are as follows. So the probability of success is how many ways can it happen over the total number of ways. So your book defines it as S over S plus F, or favorable over total. If you think about like flipping a coin, what's the probability of flipping heads? Well, heads would be success, which would be 1, over the total number of ways that can happen is 2. And probability of failure, how many ways can it not happen, would be just failure over S plus F, or unfavorable over total. If we keep talking about how many ways can we not get heads on flipping a coin, well, there's only 1 way and there's still 2. Things to think about with probability, I don't think that's on here, on this thing, but remember that probability is always going to be between 0 and 1. So the probability of some event happening is always greater than or equal to 0, but less than or equal to 1, because 100% chance, 0% chance of it happening. So make sure your answers are always between 0 and 1. So it says, when 3 coins are tossed, what is the probability that all 3 are heads? Well, think about this, that each one, if you do each one, the probability of flipping heads, the probability of flipping heads, and the probability of flipping heads, each one, there's 1 head on a coin over how many total sides? 2, 1/2, and 1/2. And what do you think we do with those? Well, this and this and this all at once. So just like the fundamental counting principle, you're just going to multiply those. So the answer is 1/8 chance of that happening. Random is when all the outcomes have an equal likely chance of occurring, which should happen unless someone's cheating. So this one says a bag can 2 coins are selected at random, so that means like there's no cheating involved. Find the probability of selecting 1 nickel and 1 dime. So the probability of a nickel, I like to put that as like probably nickel, and means multiply the probability of a dime. So how many nickels are there? There are 8 nickels. Oh, I spelled that wrong. Nickels. 8 nickels out of how many total coins are there? Well, there's 3 pennies, 4 dimes, and 10 quarters, so that's 10, 8, and 7 is 15, so that's 25. Do you agree with that? And how many dimes are there? There are 4 dimes, still out of 25 coins. So find the probability of selecting 1 nickel and 1 dime. And I don't think anything's going to reduce here, right? And so this is where you can write probability as a fraction, which would just be 32 over 625. Is that right? Yeah. 32 out of 625 chance. That's kind of a weird way to write it. And so you can also write it as a decimal, which would be 0.0512. Or you can write that as a percent. And a percent, you just move that over 2 places. So that's about a 5% chance of you randomly pulling out 1 nickel and 1 dime. So thinking about the lottery thing that we did, it can get a little more complicated. So it says Roman has 26 books, 16 are fiction and 10 are nonfiction. He randomly chooses 8 books. What is the probability that he chooses 4 fiction and 4 nonfiction? So here's where things get crazier. When you're talking about coins, I'm going to put NF for nonfiction. When you're talking about coins, every coin, whether you pull out the first dime or the second dime, it's either heads or tails. It's not a big deal. There are 16 fiction books. They're going to all have different titles, 10 nonfiction books, they're going to all have different titles. So this is an example, like the lottery one that we did, that this is going to be a combination problem. So first of all, let's think about the total number of ways. How many ways could we choose? How many total books are we choosing? We're choosing, gosh, what is my spelling problem today? We're choosing 4 fiction and 4 nonfiction. So we're choosing 8 total books out of how many books? Out of 26 books. So how many different ways can we do this? There are 26 books and we're choosing 8. Kind of like the lottery way that we did. But each one, fiction and nonfiction, there are 16 fiction, and how many fiction are we choosing? Well, we're choosing 4 fiction times there are 10 nonfiction, and of those 10 nonfiction books, we're also choosing 4. So choose the books, but because they all have different titles, this is why it's going to be different. And so I have to type this in my calculator using my combination button. So 16 choose 4 is 1820, and 10 choose 4 is 210, and 26 choose 8 is a lot. 156. 2275. So if I multiply the top there, I get 382,200. So 382,200 over 1 million ways that this can happen. And so let's see if my calculator will simplify this. It probably won't. This is where I would just write it as a decimal or a fraction. So if I change that to a percent, it was 0.2446. So that's about 24.5% chance of that happening, because the numbers are so big, leaving it as a fraction kind of doesn't make sense. I mean, we could simplify it if we want, but if there's different names on a book or something like that, this is a combination. So the only other thing I want to talk about really quick, what's my time at? 7 minutes, is multiplying probabilities, which we've done this already today. But if you multiply 2 independent events, which is what we've done so far, it says if 2 events, A and B, are independent, then the probability of both events occurring is just the probability of A times the probability of B. So drawing 3 coins or drawing the dime and the nickel, and means multiply. So to me, that's kind of an important thing. And if they're independent, it doesn't matter what the first event is because the second one is different. And so look at this example. And I don't know why my spacing is so weird. But it says Geraldo has 9 dimes and 7 pennies in his pocket. He randomly selects a coin, looks at it, and replaces it. He then randomly selects another coin. What is the probability that both coins are dimes? So we want the probability of a dime and then the probability of another dime. But what's really important about this is he replaces it. So if he has 9 dimes, there are 9 dimes out of 9 plus 7 is 16. But then he replaces it, and there's still 9 dimes, right? So 9, what is that? 81 over 256? Yes. Which doesn't reduce. You can leave that as your answer. Sometimes I think changing it to a percent, 31.6%, kind of gives you a better idea. That's independent, okay? Here's another example of an independent event. It says when 3 dice are thrown, what is the probability that 2 dice show a 5 and the third die shows an even number? These dice are all separate from each other, so what you roll on one has no effect of what you roll on the second one. So we want the probability that we get a 5, and then the probability that we get another 5, and then the probability that we get an even number. So 5s, how many 5s are there? Just 1 out of how many sides on a die? 6. And another 5, still only 1 5 out of 6 sides. And then the third one, we want an even number. So how many even numbers are there? 2, 4, and 6, right? So there are 3 even numbers. So 1 6 times 1 6, and that's really just 1/2 chance, right? So 36 times 2 is 1 out of 72, or that's like 1.4% chance of that happening. Okay, so what if it's dependent? Oh my gosh. If it's dependent, then that means the second event depends on the first one. So it says the probability of A and B, it's still, why won't this move? It's still the probability. But you have to say the probability of A times the probability of by this. Oh, I'm struggling. So it says, state if the event is independent or dependent, then find the probability. Yana has 7 blue pens, 3 black pens, and 2 red pens in his desk drawer. If he selects 3 pens at random with no replacement, what is the probability that he'll first select a blue pen, and then he'll select a black pen, and then he'll select another blue pen? But he's keeping the pens out this time, right? So how many pens are there? There's 7 blue pens out of how many total pens? 7 plus 3 plus 2 is 15. But then he's keeping the pen. So this is going to reduce to now 14 pens. And how many are black? Still 3. And then he's keeping out that pen. So now there's only 13 pens. And he already took out 1 blue one. So now we're saying there's only 6 blue ones left. And it's up to you if you want to kind of cross simplify here. I'm just going to multiply as I go. On the top there, that would be 126 over 15 times 14 times 13 is 223. Yeah, that seems weird. Does that reduce? 126 over 223 doesn't reduce any. Okay, sorry. 7 times 3 times 6 is 126, and 15 times 14 times 13 is, oh, okay, this is better. I knew I did something wrong. Is 2,730, and then that is going to reduce to